So let's review from Unit 5, the end behavior of polynomials, because we're using this again when we look at rational functions. So if you recall, the degree of a polynomial is the highest exponent. So if we have a polynomial f of x equals a sub n, the x of n plus, and then all the other terms, right? But we were looking at the first term. So this a sub n is the leading coefficient, and n is the degree, the highest exponent. So given that, if we have an odd degree, like y equals x, or y equals x cubed, or y equals x to the fifth, with a positive coefficient, then it's going to kind of be this general shape. So a positive line, this would be a positive cubic function. The higher the degree, the more possible wiggles we're going to have in the middle, but overall we're looking at the ends, the direction that the arrows are pointing on. And we know that x goes left and right, and this is positive infinity and negative infinity, and we know that y goes up and down, and this is positive infinity and negative infinity. So if we look at the arrows at the end, this arrow is showing y going positive, right? It's going up, and it's showing x also going positive. It's going to the right. So overall, this is kind of going to the right and up. Whereas this one, as y goes down toward negative infinity, x goes left toward negative infinity. So it's going down and left, the arrow. Okay, and then here we have an odd degree but a negative leading coefficient, like y equals negative x, or y equals negative x cubed, or y equals negative x to the fifth. And there could be more to it. This is just the very simplified way of looking at it. So here it's going to be like a line with a negative slope. The ends are going to go in the same direction as a line with a negative slope. Okay, and again, looking at the notation, as y goes up, x goes left. As y goes down, x goes right. Then here we have even and positive, like y equals x squared, or y equals x to the fourth. So this is going to be like a parabola, just looking at the ends, and then there's the bumps in the middle, but overall the ends are going to match that of a positive parabola. So as on this side, this end is going up and left, and this end, the y is going up and the x is going right. And then here, this will be like y equals negative x squared, or y equals negative x to the fourth. So it's like an upside down parabola. And again, we're just looking at those ends. All the stuff in the middle is different, but this is just predicting the ends. So as y goes down on this side, x goes to the left, and as y goes down on this side, x goes to the right. Okay, so then using that, we can predict end behavior. So here I have a leading coefficient of 1, and I have a degree, right? There's an invisible one there, and the degree is 3. So then I go to my chart, and this is odd and positive. So my end behavior as f of x approaches negative infinity x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity. So this first half is just looking at one end, and the second half is looking at the other end. So we're just describing the two ends of the graph. Okay, here we have the leading coefficient is -1 and the degree is 3. So we go to this one. So f of x approaches positive infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. Let's see, we can do this one over here. Here my leading coefficient is -1 and my degree is 2. So I've got even and negative. So we're in this part here. So f of x approaches negative infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. Okay. And then the last example we'll do is here with number 6. We have a leading coefficient of +1. The degree is 4. So now we have even and positive. So we're in this scenario. So f of x approaches positive infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity. All right, there we go.